Good afternoon. We're into Module 5. We're going to look at areas for rectangular items and polygons, not polygons, but parallelograms, triangles, and we'll even look at a trapezoid. Then we'll look at circles and look at the Pythagorean Theorem, and we'll have some activities for you to work through and discover these concepts. Okay, so let's go ahead and get started here. So we're going to develop the formulas and understanding of how to get rectangles, triangles, parallelograms. And Warren Beatty had this to say, you've achieved success in your field when you don't know if what you do is work or play. And I think after talking with some of you, or at least communicating about education and being teachers, for you this is a real passion. For me, this is a real passion. It's, you know, it's fun being a teacher. At least that's what I think. It's hard work, yes, at times. So sometimes we don't know whether we're working or playing, but we're often doing a little bit of both. Okay. So what is area? Well, if we have a figure, it's sort of the stuff inside it, right? So in a house, area is, we define that to be the floor space. You know, it's a two-dimensional measurement. Volume of a house, when you buy a house, it tells how many square footage. That's telling you how much floor space you have. Okay. So when you say that a shape has an area of 8 centimeters squared, so as soon as you tell the units are square units, we know that we're talking about area. We're measuring in square units. We've got 2 dimensions that we're covering. And so an item here that we could say is 8 square centimeters. One way to do it is if you have 4 by 2. What we've really done is if you divide up the 4, so you see the 4 on the top, the 2 on the bottom, and then you count how many little 1 by 1 centimeter squares there are, and there's 8. So this is where the connection between multiplication, base times height, length times width, however you want to call it, gives us the area of a rectangle. And once you understand that, everything else we're going to talk today about area, you're going to see comes right back to this base times height. Okay, everything. So we can find the area of a rectangle simply by knowing its length and its width, its base and its height. And we're going to extend that to the other types of shapes by pretty much making them into rectangles. And we're going to do it by snipping and snapping and moving and putting them into the shapes. Okay, even when we get to the circle, we're going to do the same thing. Okay, so one of the other things is when we talk about squares, this enters into here, is there are a few numbers, and this is a connection between sort of number theory and geometry. So we call these things perfect square numbers, 1, 4, 9, and 16. The numbers 2, 5, 8, and 12 are not considered perfect squares. We can get their area from a rectangle, but the only ones that come as rectangles of squares, because that is a 4, right, is 2 by 2. It's a 2 by 2 square. We get the area of 4. A 3 by 3 gives us an area of 9. A 4 by 4 gives us an area of 16, and so forth and so on. So there's this connection here between geometry, square numbers, and some interesting questions that come up in number theory as well. Okay, so parallelograms. We're going to go over this fairly quickly, but when we look at triangles and trapezoids, we're going to see that this principle basically, think of a parallelogram. It's a rectangle that has been pushed on its side. So if we cut off this little side triangle, put it over here, we've got a rectangle, but we're going to see that it's the area of the base times the height. Now it's not the slanted length of the parallelogram, it's the vertical height. So we'll go ahead and take a look at how it looks when we have this triangle. So how do we know about triangles? Let's pull this up. So here's a triangle, and we can, around its midpoint, watch, this is going to be just a nice little animation. We move this around, we can turn this triangle into a rectangle, but notice this rectangle has twice as much area. It is two triangles. So if we take, but if we were to take the base times the height, we would get the area of this whole rectangle. But that's not what we have. We only have half that area. So when we talk about the triangle, it is base times height, but we have to divide that in half because we have this, not this. Okay, so it's nice. So do take the time in the PowerPoint that's in Canvas. Go ahead and download it and play with these links. Okay, because sometimes that's, you know, when you're in the driver's seat, you see things better. Okay, that's all. So that's that one. Okay, base times height, 1/2 the base times the height. Here's another way of looking. So that was not a right triangle, and so how are we going to make this one into a rectangle? Well, again, we've got another activity here where we can show this triangle, and then we can make a copy of it and move it around, and now we've got this parallelogram, which we've talked about. What would be nice, they don't show it here, but you'll see it in another one. If we move this little triangle here over here, it would be a actual rectangle, but certainly the area is the base times the height. And again, since all we have is the triangle, we don't have this full parallelogram, we only have half of it, right? This is a double copy, there we go. So that's where those halves come from, is that to actually understand where the area is coming from, we're duplicating it and saying, hey, this is just half of a parallelogram, half of a rectangle. So another place where we can see 1/2 the base times the height. And this one, I don't understand, I'll be honest with you, I don't understand how these are labeled. I don't see, because all it says is E up here, so I don't see a J and I don't see an L. And but it's kind of a neat one, just showing you that there are multiple ways. So you can move one of the parts, you know, cut it there, flip it down, and then we can take this part. It's sort of like a parallelogram now, and if you move this one over there, you can make it into a rectangle, base times height. That's what it's going to be. And again, this is getting it down. It's got sort of a different base and a different height, but we've made it into a rectangle. So that's another way we could actually cut all the pieces and do a sort of a triple, 2 cuts and a move to turn it into a smaller rectangle. So multiple ways to understand area, but it kind of gets us all back that the area of every triangle is going to be 1/2 the base we're given times the height. And you're going to get some practice with this on, we've put some triangles on a graph area where you can actually count the length of the base and the amount of the height. Okay, one last thing to look at is this one with a trapezoid. And let's go here. And so with the trapezoid, we do the same thing. We make a copy of the trapezoid and swing it around. And you can see we've got a parallelogram. Again, we could move this H over here, or this little triangle part, have a rectangle, but we can see the base is A plus B. So the top base plus the bottom base. And then multiply times the height. And remember though, to do this, we had to make a copy. This is actually 2 figures. We only have 1 figure, not 2. So once we do the calculation, that's why we have to divide it by 2. Because again, we have this, not this. We created this to help us see that that's where the formula comes from. But in the end, we only got half we've got this area, not the full area. So that's why if you did a plus b times h, you would have this whole area. We divide it in half so that we're getting just the area of the trapezoid that we have. Okay, and so those are the series of formulas we have for rectangle, base times height, triangle, base times height, multiplied by a half because it's half the size of a rectangle. Parallelogram, base times height, because it's actually just a rectangle on its side, and so we're measuring the height. And then a trapezoid, the way of thinking of it, it's to get the full amount, we add the two bases. That's really got two bases. It's got a top base and a bottom base. Add those together, multiply by the height, but that gives you double the area, so then we cut it in half. Okay, so that's where all these formulas come from. And remember, it gets us all back to that 2 by 4 base times height. Okay, so let's take a look at circles now. And when we talk about circles, we want to talk about the circumference, the distance around the outside of a circumference. And think about it, is that 1 dimension, 2 dimension, 3? Well, it's 1 dimension. It's just, we could wrap a string around it. In fact, that's how we're going to figure it out. There is this activity. If we were in the classroom, we probably would do this. You could do this. You could draw your own circle, get some scissors, cut it out, a rubber band, do all these things. But we're going to also have a little video that we can watch, and I'll narrate it through it, and we'll come up with this formula that circumference is either pi times the diameter, or it's 2 radiuses, radii, 2 times the radius, pi, 2 pi r. Okay, so where does pi come from? Well, let's take a look at this. So what we have here is we've got a circle, and I've got it with a radius of 1 decimeter. That's 10 centimeters. Okay, and what we want to do is, since that's the radius, that's halfway from the center to the edge, so that's halfway across the circle, we're just going to see the relationship between that and halfway around the circle, not the full circumference, just half the circumference. Kind of makes sense because we're using the radius instead of the diameter. Now, if you want to use the diameter, you'd have to go all the way around the circle, but we want to shorten that up a little bit. So first I put a string, and I measure as accurately. And again, we're going to get a little bit of error here, maybe a lot, anyway, some error. So now what I want to do is I want to measure how long is that string, and all I've got is a 1 decimeter measurer, so I cut. So there's 1 decimeter, and just to let you know, I'm not moving that fast with the scissors. I'm moving kind of slowly, but I did speed up the video. But safety first always, right? And there's 3 radii plus a little bit more, and I end up with about 0.1, which is good to 1 decimal place. Yes, it should have been 0.14, so there's 3 radiuses, 3 decimeters, and 0.14. So that's where pi comes from. When the radius is 1, then halfway around the circle is 3.14 radiuses, radii. I'm not quite sure which word is which, but anyway. And so if we were to go all the way around, we would have to do that twice, right? 2 times pi times r. Okay, so that's where we get that. And then, oops, we don't need to watch this again, do we? Let's see. There we go. Bring this back. Let's move forward. There we go. Okay, so circles. So we want to explore now what's the area of a circle. So we'll do a little bit of a quick walk through this. Here's a circle with a radius. Let's draw a square inside. There it is. And notice that the area of the circle is a little bit more than this. And then we'll draw a square on the outside. The area of our circle is a little bit less than this one. So it's somewhere between these two. And if we do the math on the circle, so notice the outside is going to be, the side length is going to be 2r. So 2r times 2r is 4r. So the bigger square has an area of 4r squared. If we did the math with a Pythagorean theorem and everything, we could do that. We could find that the area of this white square is actually 2r squared. Okay, there. And so the area of the circle has to be somewhere between this. And if you remember from things you've done before, and you're remembering this formula, pi r squared, remember pi is 3.14, 3.14 times r squared. It's right between 2r squared and 4r squared. And that's what we're going to see. Okay, but this is a nice way to teach and say, hey, it's smaller than this, it's bigger than this, so it's got to be somewhere in between. And so giving us and our students a way to kind of get an estimate. Okay, so now here's a nice little activity. And again, I highly encourage you to click on this one and give this one a try. So notice there's kind of like a string around here, and we're going to unwrap that. So there's its circumference of a circle all the way down. And then you click on this and it says, okay, so now what we're going to do is we're going to dissect the circle, the area of the circle, into, this does 12 parts, but notice you could do more, you could do less, so you could change this, you know, however you want, 14 parts, 12 parts. You could do fewer. But let's just go ahead and do it with 12 to start off with. And then what we're going to do is we're going to rearrange them, and you're going to see it kind of does the same thing it did with the circumference. It wraps it down, and we slap it down there, and you can see a whole circumference, right? The whole outside. But notice they've got these colors, and so what kind of a shape is this? This kind of look like, you know, it's not a rectangle yet. But if we keep going and we put the purple or the blue, whatever that is, inside the red, we can see we can make this into a rectangle, parallelogram maybe more. The smaller the pieces we cut it into, the more pieces we cut it into, the smaller they'd be, the closer it would be to a rectangle. But we can see this area has a height of r, so we're going to multiply by r, and its length is half of a circumference. Half of a circumference is, remember, circumference is 2 pi r, so half of that would just be pi r. Pi r times r is pi r squared. So that is the area of this circle. And remember, I told you that all that we were going to do today as far as area will all tie back to the formula for a rectangle. So once we understand the rectangle, everything else just comes from it. When I first, and again, we learned this as students, and at least I did. I saw everything as separate, you know, learning all these formulas and everything, until I started teaching it, and then I came across something like this. I said, wow, as long as we know how to do the area of a rectangle, that's really all we know how to do. Everything else is related to that. I was no longer impressed with geometry. It made it, well, I guess I was impressed with how connected it was, but it certainly seemed more compact after that. Okay, and then so the area of a circle, again, you could keep going, making 16 pieces, more pieces, and you would see your area is going to be pi r squared. Pi, remember, 3.14 times the radius squared, and that will give us the area of a circle. And again, from that big circle, big square, little square inside, it makes sense. It's between 2r squared, 4r squared. It's in fact actually right in half. And the last thing to look at today is Pythagorean theorem. We're not going to spend too much time, just that it is what it is. It's a physical reality of right triangles, that the two legs, the parts that are on either side of the right angle, A and B, if you square those and add those, you get the area of the longer side squared, the hypotenuse. So a squared plus b squared is going to be equal to c squared. And there's a interesting little YouTube video to watch, and we'll do that. Got a little bit of volume here, which is kind of good, I guess. Let's turn it down a bit. Here's water, and there's your two little squares. You're adding them together, and watch, it's going to perfectly fill up that bigger one. This is probably a lot more work than I would go to. It's, I'm sure it involves some shop class or something. And then you could go back the other way. The big square can go fill up the other two little squares. But a great little video to show the geometric relationship of the Pythagorean theorem. Again, there's other ways to do it, but this is a very a quick and convincing way to look at the Pythagorean theorem. Okay, so we square these, we can find. Now remember, that's giving us c squared. If we need to find what the actual length of c is, then we're going to need to use a square root. But that's what we have for today. See, that's it. So what I'm going to do now is let's take a look. Let's come back here. Let's take a look at the assignments we have. Let's go with area of triangles first. Okay, so we want you to find areas of these triangles. And again, you're going to count along here for its base and the height, multiply, and remember to take half of it. You could count also all these little squares in here and add up these parts, however you need to do it. Let's see, something's jumping around on me. Okay, let's go ahead and close that one out. Oh, sure, why not? We'll save it. Okay, so back here. Okay, and then some more questions, triangles here. They're in different orientations. So again, you're going to want to choose carefully what you call the base and then the height. Some of them may be harder. You might need to use a Pythagorean theorem thing to actually come up with what the base is and what the height is. So a little bit of challenge. And this one is an explanatory thing. How could you explain? And so think back to those videos or those little applets that we saw of how you can explain the area of a triangle being 1/2 the base times the height. And then here's a interesting little shape to try to figure out just the shaded part. So obviously you've got to figure out the bigger piece. These pieces have been cut out, subtracting them, and using this idea that area does not change if it's you know, we're not stretching it. No, we're not stretching it, but we're cutting pieces out. And if you cut those out and remove them, that's the addition subtraction of area. Okay, and again, you could find the big rectangle, take off the pieces, however you want to do it. But it's problem solving for you to go through and figure out how to get this area, and then show your work there. And then there's this one. So there's two that we have for you to do. This one, you can find the area of a parallelogram. And again, remember base times height. So that's right there. Here's a sort of a little bit of problem solving to do. You've got a rectangular centerpiece with two circles on it. The two half circles, you could put them together, make one circle. And they want you to find the area and the perimeter. So we're going to have to add things together and figure out how to do that, and just kind of go step by step. This one's going to be a little challenging, I guess, because they don't give you the radius. So we've got that a garden path surrounds a garden, and it's shown the garden path is 5 feet, so we know the width of this sidewalk, this path around it, and we know that the distance around the outside of the garden path, so I'm going to assume that that's the outside of the garden path, is the bigger circle, is 80 feet. So that's our circumference. So we know the circumference is 80. That will allow us to be able to figure out what the radius is of the big circle. And again, once you've got the radius of the big circle, you subtract 5 from it, you'll have the radius of the smaller circle, and then you can find that area. You can find the area of the big circle, subtract the center part, and you'll have the area of the path. Okay, so, and again, just kind of go through there, explain your reasoning. There is a rectangle here. It's hard to see. They want to know the diagonal. So this is one with the Pythagorean theorem. And the last one here, you'll need to use the Pythagorean theorem to figure out the distance between two. They give you due south, so they give you a right angle. You've got your two legs, figure out the distance of the other one. So those are your hand-in assignments with the Pythagorean theorem, with circles, with areas of triangles. And that's all we're going to have you do for lesson number 5. Okay, and so I pre-recorded this because there was a few technical things I wanted to make sure I got through, which would have been hard to do live in class. I'm going to post this in Canvas. Obviously, that's where you're seeing it. Send out an announcement, and then during class time, we can meet for any additional questions. All right, be well. And remember, once you understand the area of a rectangle, you understand area.